All right, in lesson 9.3, we're going to take a look at two-way tables. And if you're not sure what a two-way table is, just hold on, because I bet that you've seen them before or you're more familiar with them than you might think. So how do we read one? And then how can we create one? Because two-way tables just allow us to put data together and make it easier to interpret and to read. So rather than looking at a whole bunch of information that's all spread out, it really puts it into a nice, organized, concise place for us to look at and be able to answer questions quickly. So let's take a look. If I asked you to complete this table, I bet you would know exactly what to do. So we have to figure out the totals for the rows, so find out all of these totals, and for the columns. So we got to find the total down here. So go ahead, take a minute, and calculate the totals for both of those. All right, so the totals that I got for the rows were 12 blue and white shirts, 16 blue and gold, 14 red and white, 11 black and white, and 12 black and gold. Now, just to double check and make sure that I know what I'm talking about, if I add up all of these, they should total 265. And they do. They work out. So then, hopefully, we did our math correctly, right? But it's just another way for you to double check yourself and make sure that you're on the right track. 65. Okay, now if I total up the columns, I have 20 small shirts in stock, 18 mediums, 14 larges, 5 extra larges, and 8 double extra larges. Again, if I total all of these, if I add them together, I do indeed get 65, which is the total number of shirts that we have in stock. Now for part B, are there any black and gold extra large t-shirts in stock? Justify. Black and gold. And we're looking for, so this is my black and gold, right? And we're looking for extra large, so that's this column. And that number is a 0. So are there any? Nope. There are no extra large gold, black and gold t-shirts left because on our two-way table, we can see very quickly that that number is 0. The quantity is 0. All right. The number of shirts that we ordered at the beginning of the year, so this is what we were left with at the end of the season. That's how many we had left, 65 shirts left over. I want to know the totals that we had from the beginning of the year. So go ahead, add up all of the rows and all of the columns. All right, hopefully you recognized for every single color shirt, blue, white, blue, gold, red, white, black, gold. They ordered 5 smalls, 6 mediums, 7 larges, 6 extra larges, and 5 double extra larges. So the total is 20. Did you need to recalculate that every time? Hopefully you didn't. Hopefully you recognized it. Every single t-shirt color would have a sum of 29. Now, if we were sitting in class together, I would ask you, why do you think they changed up the number that they ordered per size? This is where your interpretation comes into play. Typically, I have responses like, well, the average person would wear a large, and then there's less people who wear mediums and extra larges, and there's even less people who wear smalls and double extra larges. That's a reasonable answer. You could be thinking if these are adult sizes, right, or for kids in our high school and adults, the majority might be large. All right, makes sense. So if we total, we can see that the smalls and the double extra larges both have 25 because we got 5 of each of them. The mediums and the extra larges both have 30, and then the largest have 35. Now, did we do our math right? Well, adding up or taking 29 times 5 over here, we get 145. Well, adding the sum of all of the sizes, right, we also get 145. So our totals match up. Now, this last part, this is the part that I'm really interested in. What is your interpretation of the information? How would you alter the number of t-shirts you order for next year? So this is what you ordered this year, and this is what's left. What would you do? Would you order more of a certain color or less? Like, let's take a look here. We have 20 smalls left over, and we only ordered 25 to start with. So you might want to order less smalls next year. Let's go back. Ooh, we ran out of extra larges in 2 colors, blue and white and black and gold. And there's only 5 left. So maybe next year, we might increase the number of extra large shirts that we order. You could come up with a lot of other interpretations. Those are just an example of a couple that I came up with right now. But that is why I like data and stats so much. Because you take the math, but then you get to interpret it and see what it means to you. All right, let's do a couple examples. And like I said, if you just want to work through this whole lesson and do all of the examples on your own first, go for it, and then come back and check with the video. If you want to kind of go with me as I go, that's fine too. So we surveyed students about country music. Do you like it? Yes or no? And then, are you male or female? So question A says, how many female students like country music? So they have to be in this female row, and they also have to be yeses. Well, those two intersect at 18. So there are 18 female students that like country music. Now the second question here, how many male students do not like country music? How many male students do not like country music? Okay, so we got male, right, the row here, and they do not like it, so it's the no column. And we can see that that is 28 males. Now, I'm going to make you think a little bit more. What percent of males do not like country music? Percent. So we have 28 that do not like it out of how many males were asked total? Just the males, that's all I'm asking about. 28 and 24 total, right? We have to take that sum. All right, there's 52 total then. So 28 out of 52 males do not like country music, which if we calculate that, that is approximately 54% of the male students do not like country music. So these tables just allow us to get this information quickly and be able to interpret it, and then we can even go further, not just complete the tables, but we can look at the results or percentage breakdowns of what this means. All right, so take a look at number 2. For the first part, it says how many students in the survey studied for the test and passed. So studied is this first column, then passed is our top row. So I want to know which ones did both. That's why it's called a joint frequency, because we're looking at two different characteristics. So for number 2, how many studied and passed? 21 students. The second part, this might be new vocabulary, but it's actually not anything new. It says find and interpret the marginal frequencies. Marginal frequencies are when we're just looking at those totals that we did on those previous examples. So if I want to know how many total kids passed, 21 and 2 is 23, just like we wrote the totals on the right-hand side previously. Well, how many kids total failed? 7. Those are my marginal frequencies. Okay, we also can figure out the marginal frequency for how many studied and how many did not study. So how many kids studied total? 22. How many kids did not study at all? 8, right? I'm just totaling now on the columns. Then we can figure out how many kids did we ask altogether. Well, 23 and 7 gives me 30. And guess what? So does 22 and 8. We get 30. So we asked 30 students total. Now I know the question doesn't ask this, but I like to make you think. For number 2, it said how many students in the survey studied and passed. I want to know what percent of students studied and passed. So I had 21 kids that studied and passed the test out of how many total? We figured it out. It was 30. And if we convert that to a percent, that is exactly 70%. So again, the question didn't ask that, but I wanted you to be thinking about how we can use this information to quickly get the results that we're looking for. All right, last example for this video. Pause if you want to go ahead and work through it. Letter A, how many students will attend the dance but not the football game? So they attend the dance, yes, but they do not attend the football game. Well, where does that overlap? Right there at 5. So 5 students will attend the dance but not the football game. Okay, now, like we did on the last example, find and interpret the marginal frequencies. So we got to find those totals. How many kids total attended the dance? 35 and 5 is 40. So our interpretation is 40 students total attended the dance. How many did not attend? 16 plus 20 is 36, for a grand total of 76. All right, we got to figure out how many kids attended the game. 35 plus 16 is 51. 5 plus 20 did not attend the game, so 25 kids did not. That interpretation is just telling me what those total mean. So 51 attended the game, 25 did not attend the football game. And once again, 51 and 25 gives me a total of 76 kids. All right, we're going to pause here for lesson 9.3, and in the next video, you're going to learn how to actually create two-way tables just from data.